Hi dear students, in this video I am going to explain about the two important chapters in your syllabus, that is organic chemistry and hydrocarbons. So both are very much important for final exam. Try to concentrate on these two big chapters. So first we will see about organic chemistry. Organic chemistry is very important chapter and you will get totally 11 marks from this chapter. So total weightage of this chapter is 11 marks. From this 11 marks, you will get one 1-mark question and two 5-mark questions. 5-mark questions, totally you will get 2. 1-mark question 1 and 5-mark questions 2. There is no direct 5-mark question. You will get this 5-mark question as 3 plus 2 or 2 plus 2 plus 1. There is no direct 5-mark question. So in this manner, the question will be asked for 5 marks. So total weightage is 5 into 2, 10 marks, and 1 into 1, 1 mark. Total weightage is 11 marks. So totally you will get 11 marks from this chapter. Now we will see the important concepts where you want to concentrate from this chapter. So first you want to know what is meant by organic chemistry. Organic chemistry is a branch of science which deals about the carbon compounds. Okay. So then you want to know about the hybridization of carbon atoms. Hybridization of compounds. Hybridization of carbons, because specifically here we are studying about carbon atoms or carbon compounds, so we want to know about the hybridization of carbon atoms. So first, Sp3 type of hybridization, second Sp2 type of hybridization, third one Sp type of hybridization. It is enough to know about the 3 important types of hybridizations. So where you can see this Sp3 hybridization means, so this we can see in a compound in which between the 2 carbon atoms single bond is present. In single bonded carbon compounds, we can observe the presence of Sp3 hybridization. If suppose the 2 carbon atoms are connected by double bond, just imagine. The valency of the carbon is to have totally 4 bonds. Okay, here 2 bonds are satisfied by 2 other atoms and the other 2 bonds are by the double bond. So if between the 2 carbon atoms, if a double bond is present, then those 2 carbon atoms involved in Sp2 hybridization in case of double bonded carbon atoms. Next, Sp type of hybridization we can observe in a carbon compound where the carbon atom is involved in the formation of a triple bond. This carbon has triple bond, even this carbon has triple bond, then its hybridization, these 2 carbons hybridization is Sp. So in the case of triple bonds or triple bonded carbon atoms, we can see the presence of a Sp type of hybridization. That is about the hybridizations of carbon atoms. There are 3 important hybridizations: Sp3, Sp2 and Sp. So in Sp3 type of hybridization we can observe in carbon-carbon single bond, Sp2 we can observe in carbon-carbon double bonds, Sp we can observe in carbon-carbon triple bonded compounds. So then we want to see, here I will give, we want to see number of sigma bonds and number of pi bonds. Number of sigma and number of pi bonds in a compound we want to find out. Just remember, if a single bond is present, that single bond is completely sigma bond. If a double bond is present, between any 2 atoms, in that double bond one is sigma, one is pi. If a triple bond is present, in that triple bond we can see 1 sigma bond and the remaining 2 bonds are pi bonds. Okay, total number of sigma and pi bonds, how to calculate? In a compound, if only single bond is there, that is completely sigma bond. If double bond is there, one is sigma bond, other one is pi bond. If triple bond is there, only 1 sigma bond, other 2 are pi bonds. In this manner we can find out. Example, we will take a compound, that is CH triple bond, C bond, CH double bond, CH, CH3. In this compound we want to find out the total number of sigma bonds and pi bond. Remember, there is no bond between carbon and hydrogen, but it is understood between them a single bond is present. If it is a single bond, that is completely sigma bond. That means between carbon and hydrogen. If you want, you can write in a complete structure. Carbon, now it is a single bond with a hydrogen, triple bond. Then carbon, on this carbon its valence is satisfied. Here 3 bonds, here 1 bond, there is no hydrogen. Next carbon, upon carbon one hydrogen is present, that is with a single bond, double bond. Carbon which is with one more hydrogen, that we can write here, or below it, it's not a problem. Next single bond, carbon, on this carbon 3 hydrogens are there, those 3 hydrogens we will write like this. Okay, now you can count the number of sigma bonds and pi bonds. If only single bond is there, that is purely sigma bond. Okay, now it is sigma bond. Here triple bond is there. In a triple bond, one is sigma bond. This is single bond, sigma bond. Here double bond is there, one is sigma bond. And between carbon and hydrogen only single bond, sigma bond. Between carbon and hydrogen only single bond, sigma bond. Even this is single bond, sigma. Even this becomes sigma, this becomes sigma, this becomes sigma. Total number of sigma bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of sigma bonds are 10. Then number of pi bonds. So these two are pi bonds. In a triple bond, 1 sigma bond and 2 pi bonds. These two are pi bonds. In a double bond, 1 is sigma, 1 is pi. This is pi bond. 2 plus 3 total. So 2 plus 1, that is totally 3 sigma bond. 3 pi bonds are there. So like this we can find out the number of sigma bonds and pi bonds. Now I will give few questions for homework. You try to find out its hybridization as well as number of sigma bonds and pi bonds. That is CH2 double bond O, CH3 F, CH triple bond N. This is first, second, third. Next two more I will give. Fourth one, H, C triple bond C, CH2, CH2, CH3. This is fourth one. Next fifth one, another one is CH3Cl. For these 5, try to find out hybridization and number of sigma and pi bonds. So this is homework for you. Try to do this and send answers to me. Now our next topic in this chapter is bond line structure. Here you want to find out bond line structure for the given hydrocarbon or organic compound. They'll give a organic compound. There are 4 different methods to represent a organic compound. That is bond line structure, complete structure, condensed structure, Lewis dot structure. Among all, bond line structure is very much important for 1 mark. They'll give a compound. For that compound you want to write bond line structure. In this bond line structure, what we want to do? We want to represent the carbon and hydrogen's carbon-carbon bonds only by using lines. We need not to represent about carbon and hydrogen. Carbons and hydrogen we never represent. Okay. Any other heteroatom is present. If heteroatom is present, such heteroatoms we want to represent specifically. And double bond is indicated by 2 lines, single bond is indicated by 1 line, triple bond is indicated by 3 lines. In such a way we can represent about this bond line structure. In a bond line structure we don't write carbon and hydrogen. If any heteroatom like oxygen, nitrogen, sulfur are there, such type of heteroatom is nothing but the atom other than carbon and hydrogen, that is called heteroatom. Such heteroatoms we can represent specifically. Clear? Heteroatoms can be represented specifically in bond line structure. The single bond present between the 2 carbon atoms indicated by single line, double bond is indicated by 2 lines, triple bond is indicated by 3 lines. In such a way we can represent this bond line structure of organic compounds. We will see examples. Here I am taking one of the example, that is just example 1, CH3, CH2, 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 CH3. This compound we want to represent in bond line structure. So between only in this compound carbon and hydrogen is there, need not to represent that carbons and hydrogens. The bond present between the carbon and hydrogen should be indicated by a line. All are with only single bonds, represent with single line. First you just give numbering, first carbon, second carbon, third, fourth, fifth. So first between first and second carbon single bond is there, write with single line. Second and third single bond, this is second and this is third. In zigzag manner only we want to represent. Next, between third and fourth a single bond, between fourth and fifth a single bond. If you want you can check with by giving numbering 1, 2, 3, 4, 5 bonds or 5 atoms is balanced. In this way we can represent bond line structure. We will see one more example. CH2 double bond, CH bond, CH double bond, CH2. Here double bonds are present between the carbon atoms. First give numbering 1, 2, 3, 4. This numbering we are giving just to cross check, that's it. There is no rule to give numbering for the atoms. Between first and second carbon which bond is present? Double bond, represent it with two lines. And between second and third carbon single bond. Between third and fourth carbon double bond is present. Then we will represent like this. Now give numbering, first carbon, second carbon, third carbon, fourth carbon. Like this we can represent. Between first and second double bond, between third and fourth double bond. Now clear. Next, third one. For example, CH3, CH2, 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 OH. Now we want to represent this compound. Here there is a heteroatom oxygen. Okay, so you just remember that one. First give numbering for the carbon atoms 1, 2, 3, 4. First write all the 4 carbon atoms. Between carbon and hydrogen, carbon and carbon which bond is present? Single bond, represent it with single line. Between second and third carbon single bond with single line. Between third and fourth carbon single line, represent with single line. Now it is a heteroatom. On heteroatom a hydrogen is present, then this hydrogen must be represented. If hydrogen present on carbon, need not to represent. If hydrogen is present on any heteroatom, we want to represent. On fourth carbon OH is present, that is with a single bond. Write a single bond and OH here. That's it. First carbon, second carbon, third carbon, fourth carbon, balanced. Like this we will represent. And we'll see one more example. That is CH3, CH2, OH, otherwise CH3, CH double bond, CH bond, CH2, CH3. Okay, give numbering first 1, 2, 3, 4, 5. Write with the bonds. Between first and second carbon single bond is there, write with single line. Between second and third carbon double bond, write with double line. Between third and fourth carbon single bond, single line. Between fourth and fifth carbon single bond, write with single line. 1, 2, 3, 4, 5. Like this we will represent. Okay. So this is very much important for 1 mark and compulsory question. So they will give a compound, for that you want to write the bond line structure. Try to practice as many as possible. Now we will see the next topic. Now we'll see another most important topic from this chapter, that is nomenclature. So nomenclature is a system which is used to give names for an organic compound. Organic compound is made up of only carbon and hydrogen. For such type of organic compounds we will give their names based on this nomenclature. There are two important nomenclatures. One is Iupac nomenclature, other one is the common nomenclature. So first we will see Iupac nomenclature, and this is only asked for exam. Iupac nomenclatures. To write Iupac nomenclature, you want to remember 3 important words, that is root word, suffix and prefix. Root word will always represent at the middle. After root word, whatever the word we will represent, that is called suffix. Before root word, whatever we will represent, that is called prefix. These 3 you want to remember. So root word always indicates about the number of carbon atoms. Number of carbon atoms. Okay, I'll write here. Root word represent about the number of carbon atoms. If 1 carbon is present in a compound, only one carbon is present, then it is called meth. If 2 carbons are present, we will call it as eth. If 3 carbons are present, we have to pronounce it as prop. 4 carbons, but. If 5 carbons are present, pent. 6 carbons are present, hex. If 7 carbons are present, hept. 8 carbons are present, oct. If 9 carbons are present, none. If 10 carbons are present, dec. It's enough to know only till 10 carbon atoms at this level. So, root word always represent about the number of carbon atoms. With 1 carbon atom, we have to write root word as meth. With 2 carbon atoms, eth, and so on, like this we will represent. After root word, whatever the other word will come, that is called suffix. So, there are 2 important types of suffixes, that is primary and secondary. So, primary suffix always represent about the nature of bond. Primary suffix represent about the nature of bond. So, if single bond is there, then the suffix is ane. If double bond is there, we will write the suffix as ene. If triple bond is there, the suffix is ine. Primary suffix always represent about the nature of bond. Single bond ane, double bond ene, triple bond is ine. Next, secondary suffix always indicate about the functional group. Functional group. Secondary suffix represent about the functional groups. There are many functional groups are there. Example, COOH. The suffix is oic acid. C double bond O. Suffix on. CHO. Suffix Al. OH. Suffix is OL. NH2. Suffix is amine. SO3H. Suffix is sulfonic acid. So all these represent about the functional group, that is secondary suffix. If COH group is there, secondary suffix we want to write it as oic acid. If C double bond O is there, suffix we have to write it as ONE. CHOAL, OH, OL. Like this we will represent about the suffixes. Now come to the part of prefix. This is the word which is represented before the root word. So this prefix is of 2 types, primary prefix, secondary prefix. Primary prefix always represents about the cyclone. It is applicable only for the cyclic compound, especially alicyclic compounds. For alicyclic compound, we will write this primary suffix as cyclo. Next, secondary suffix. This represents about the substituents. Substituent like halogen. If X is there, we will write the prefix as secondary prefix as halo. If NO2 group is there, prefix we will write it as nitro. If NH2 group is there, prefix we will write it as amino. Like this prefixes we will use for the substituents, okay, for secondary prefixes. But no rule that compound should contain all the 5 words. Few may contain all the 5, few may not, but root word and primary suffix is compulsory for all the compounds. For example, if a compound is containing only 1 carbon with single bond, then we can call it as meth plus primary suffix for single bond is ane, we will write it as methane. Like this we will represent. So that is about the nomenclature and the words what you want to remember. So 3 words you want to remember: root word, suffix and prefix. Root word represent about the total number of carbon atoms. This is about the number of carbons with root word. So the word which comes after root word is called suffix. Suffix is of 2 types, primary and secondary suffix. Primary suffix represent about the nature of bond. Secondary suffix indicates about the functional group. Next, prefix is of also 2 types, primary prefix and secondary prefix. Primary prefix represents only cyclo. It is applicable for only alicyclic compounds. Whereas secondary prefix is used to represent about substituent. Substituent is nothing but other than one functional group, remaining all functional groups and other groups becomes the substituents. So we will use these as secondary prefixes for representing substituents. Now we will see few examples, then you will come to know. So here I am taking few examples. Okay, first example, CH3, CH2, CH3. For this we want to write IUPAC name. First take the parent chain. Only one possible chain is there. There is no substituent and there is no side chain, straight chain. So that has to be considered as the parent chain. Now you want to give numbering. Either left to right or right to left you will give. There is no substituent, there is no functional group. Either of the side you can give. I am giving from left to right. First carbon, second carbon, third carbon. So there is no functional group, there is no substituent, there is no multiple bond. Directly you can write its name. Total number of carbons are 3. With 3 carbon atoms, what is word root? Prop. There is no primary prefix. It is applicable only for cyclic. It's not cyclic, it is aliphatic. Secondary prefix is also not there because there is no substituent. Then directly root word. Root word with the 3 carbon atoms is prop, right? Prop. Then primary suffix, nature of bond. Which type of bond is present? Single bond. If single bond is there, what is the suffix? In. You just add the word in. Now secondary suffix. There is no secondary suffix which represents about functional group. There is no functional group. That's it. Its name is propane. Now we'll see one more example. CH3, CH2, CH2, CH3. Okay. First select the parent chain. Only one possible chain is there, that becomes the parent chain. Now give numbering. Okay, either of the side now you can give because there is no substituent, there is no functional group. I am giving from left to right. 1, 2, 3, 4. Okay, so with 4 carbon atoms, no substituent, no primary prefix, no secondary prefix, directly word root. With 4 carbon atoms, root word is but. Write that but. And single bond is nature of bond. Single bond is that suffix is ane. Directly we will write butane. And there is no secondary suffix. Next, third one, CH3 bond CH double bond CH bond CH3. Now we want to write its name. Select the parent chain. Longest carbon chain becomes the parent chain. Now give numbering. So see, double bonded carbon or triple bonded carbon is there, that must get the lowest number. In that way only we want to give numbering. You can give from left to right or right to left. If you give left to right, first carbon, second carbon. Double bonded carbon will get the second number. If you give from right to left, first carbon, second carbon. Even this is double bonded, it is also getting second number. So from both the sides it is getting the same number. You can give any one way. First, second, third, fourth. With 4 carbon atoms, root word is but. And now its nature gets changes because it has a double bond. With double bond the suffix is ene. The double bond is not at first position, it is at second position. So you have to mention its position to ene. That means double bond is now present at second position. But to ene. That's it. Next we'll see one more. This compound. Now select the parent chain. The longest chain, continuous carbon chain becomes the parent chain. Now this is parent chain. Give numbering from right to left or left to right. If you give left to right, double bond, triple bonded carbon should get the lowest number. If you give from left to right, double bonded carbon, first carbon, second carbon, it will get second number, and triple bonded carbon will get the fourth number. If you give from right to left, triple bonded carbon will get the first number, double bonded will get the second number. So this is the way in which we can give a minimum number for the double and triple bonded carbon. So give numbering from this side. First, second, third, fourth, fifth. Okay. So with 5 carbon atoms, what is word root? Pent. Right? Pent. And double bonds. If double, triple both are there, then you want to write ene, ine as suffix. First you want to mention ene, then you want to mention ine. So ene is nothing but presence of double bond. Double bond is present at which carbon? Second carbon. So we will write pent 3 ene. Next, double bond, triple bond is present at first carbon. So pent 3 ene, 1 ine. Like this we will represent its name. Like this you want to try as many as possible, then you will get the answers. I will give 2 examples here. Next one, CH3, CH double bond, CH bond, CH double bond, CH, CH3. Write name for this one. Next one, CH triple bond, C bond, CH 2 bond, CH double bond, CH2. Try this for. So these two are homework for you. Try to write IUPAC names for these two and send answers to me. That is about the IUPAC nomenclature, which is very much important for 1 mark. Now we'll see the next topic. Now we'll see one more important topic from this chapter, that is isomerism. So isomerism is a phenomenon which explains about the isomers. Isomers are the organic compounds having the same molecular formula but differ in the structures. Those are said to be isomers, and the phenomenon which is used to explain about isomers is called isomerism. There are 4 important types of isomerism. In that, the first one is chain isomerism. So chain isomers are the isomers which differs in the length of carbon chain present in a molecule. Okay, so they are having same molecular formula but differ in the length of chain. Same molecular formula but differ in the length of carbon chain are called chain isomers, and the phenomenon used to explain it is called chain isomerism. So example, we will take N-butane, CH3, CH2, CH2, CH3. So here all the carbon atoms present in the straight chain normally, so we can call it as N-butane. Another isomer for this is isobutane, that is CH3, CH, CH3, CH3. This is called isobutane. Both are containing same molecular formula but differ in the structure. So we can say our length of chain is differs. In this, the length of chain is 4. In this, the length of carbon chain is only 3. Then such type of isomers are called chain isomers. Now the second one, position isomers. This is very important compound, very important concept. From this compulsory you will get 1 2-mark question. Okay, compulsory 1 2-mark question will be there for the final exam. Position isomers. So the isomers which are having the same molecular formula but differ in the position of a functional group, then those are said to be positional isomers, having same molecular formula but differ in the position of functional group or substituent. So example, CH3, CH2, CH2, Cl. Now this is the parent chain, only carbon chain we want to consider. Substituent containing carbon we want to give first number, second one, third one. This is propane. At propane, first carbon containing chlorine, so we can call it as 1-chloropropane. 1-chloropropane. And we can also write another formula for the same, another structure with the same molecular formula, that is CH, Cl, CH3. Here this is the parent chain, give numbering. First carbon, second carbon, third carbon. At second carbon now chlorine is present, we can call it as 2-chloropropane. 2-chloropropane. That is about positional isomers. Now these two are having same molecular formula, only the position of halogen is getting changed. In this case only one chlorine is first position chlorine is there. In this case second position is with the chlorine. So whatever the compounds having same molecular formula but differ in the position of functional groups or substituents are called position isomers. Now the third part, functional isomerism. So the compounds which are having the same molecular formula but differ in the complete functional group. So functional group totally changes from one molecule to other molecules, then those are said to be functional isomers. So example, I am taking here CH3O CH3. This is called dimethyl ether. With the same molecular formula we will write one more compound, that is CH3 CH2OH. This is called ethanol. In this case the functional group is alcohol, in this case the functional group is ether. So both are having same molecular formula but differ in the functional groups, then those are said to be functional isomers. Among the three types, one is compulsory for 2 marks. Okay, that is about isomerism. Next, another important concept is you want to concentrate on inductive effect, mesomeric effect, hyperconjugation. Along with these three, you try to read two more important questions, that is differences between inductive effect and mesomeric effect. Next, differences between inductive effect and electromeric effect. So these two are very much important. From these two, one is compulsory for 3 marks, even for the final exam. Among the differences between inductive effect and mesomeric effect, differences between inductive effect and electromeric effect, one is compulsory for 3 marks. Okay, that is about the chapter organic chemistry and the topics where you want to concentrate for the final exam. Now we'll see one more important chapter from your syllabus, that is nothing but hydrocarbons. So now about the chapter hydrocarbons. So these hydrocarbons are the organic compounds which contains only carbon and hydrogen. So hydrocarbons are the organic compounds which contains only carbons and hydrogens. In this chapter you want to study about alkanes, alkenes and alkynes. Alkane and alkynes are containing only carbons and hydrogens. All these are said to be organic compounds which is made up of only carbons and hydrogens. And along with that we want to study about aromatic hydrocarbons. Okay, only these are the 4 topics what we want to concentrate from this chapter, that is hydrocarbons: alkane, alkene, alkyne and aromatic hydrocarbons. So first we will see one by one and questions based on this alkenes, alkanes, alkynes and aromatic hydrocarbons. Firstly, what is LPG? Expand LPG. LPG is nothing but liquefied petroleum gas. LPG stands for liquefied petroleum gas. Next, another expandation is CNG. CNG is nothing but compressed natural gas. Compressed natural gas. Next, another one is LNG. LNG is nothing but liquefied natural gas. Liquefied natural gas. Okay. So these 3 are important for 1 mark. There is a chance to ask about expand LPG, CNG and LNG. Now we'll see another important question. That is, what is Wood's reaction? Wood's reaction. I forgot to tell about the weightage of this chapter. So from this chapter you will get only 10 marks. Total weightage of this chapter is 10 marks. So you will get 1 mark question, 2 mark questions and 1 5 mark question. That is 1 into 1 1, 2 into 2 4, 5 into 1 5. Total weightage is 10 marks. Okay, so that is about the weightage of this hydrocarbons chapter. Now another important question the topic is Wood's reaction. So this Wood's reaction is used to prepare alkane as the final product. When alkyl halide is indicated by RX. R is alkyl, X is halide. Alkyl halide. reacts with sodium metal, 2 sodiums, and we want to take 2 moles of alkyl halide. The same alkyl halide even here I am taking in reverse manner. This is alkyl and this is halide. So when 2 moles of alkyl halides react with sodium metal in presence of dry ether, it releases NaX, 2 NaX in presence of which one? Dry ether. It releases 2 NaX. What is left? R and R. Between them a bond is formed and we will get R bond R, plus it releases 2 NaX. This is called alkane is formed. When 2 moles of alkyl halides react with sodium metal in presence of dry ether, they can form alkanes as the final product. You can also write one example. In place of R group, you will take any alkyl group, methyl, ethyl, propyl and so on. I am taking methyl, CH3, and in place of X, I am taking Cl plus 2 Na. Even in place of X, what we will take? Cl, and in place of R, we will take CH3. So here also what happens? So 2 Na react with 2 Cl in presence of dry ether, it releases 2 NaCl. And what are the two groups left? CH3 and CH3. These two combined with each other, we will get CH3 bond CH3 plus it releases 2 NaCl. This is called ethane. 2 carbons are there, we will call ethane. So this is very important question and compulsory question for 2 marks. What is Wood's reaction? When 2 moles of alkyl halides react with sodium metal in presence of dry ether, they can form alkanes as the final product. You want to write general reaction as well as example. And next question is, what is soda lime? Soda lime is a mixture of NaOH and CaO. It is also important for 1 mark. Okay, and next question, explain the preparation of this alkane by using sodium salt of acid. Okay, preparation of alkane from sodium salt of acid. Okay, alkane we want to sodium salt of acid. I am taking here CH3COO Na. When it reacts with soda lime, what is soda lime? NaOH and CaO. NaOH and CaO. So what happens? Na2CO3 is released. Na2 CO3 minus Na2CO3 is released. What is left here? Hydrogen. This hydrogen is added to CH3, then CH3 becomes CH4. Finally, we have prepared alkane. Okay, alkane can be prepared from sodium salt of acid. Now we'll see the next one. So next question is coal-based electrolysis. This is also important method which is used to prepare alkanes. When 2 moles of sodium salt of acid, example I am taking CH3COO Na plus CH3COO Na. When these two undergo hydrolysis, that is addition of water, okay, this will take place in presence of electrolysis reaction or process. 2H2O I am taking. So this 2H2O is containing OH, H, OH, H. Okay. So what happens? Na2CO3, Na and OH react together to form NaOH. Na and OH together to form NaOH. And exactly here the bond gets breakage. Okay. So CO2 is released and CH3, H is left. CH3 and H is left. So these two hydrogens react together to release H2. Between CH3 and CH3 there is a bond is formed, then we will get CH3 bond CH3, that is ethane, alkane is formed, plus 2 moles of CO2 is released. This is CO2, CO2, plus 2 moles of NaOH is released. NaOH is in 2 moles, plus H2 gas is released. So that is about the coal-based reaction. Next, we'll see one more reaction. Next question is, write representations, projections, Sahar's projection and Newman projections of ethane. Sahar's and Newman projections of ethane. This is another important question which is important for 2 marks or 1 mark, compulsory question. Now we'll see one more. Another one is preparation of alkene from vicinal dihalides. Next one, Markovnikov rule, Sage's rule. Very important, these two rules for 2 marks. Now we'll see one more. Next question is addition reactions of alkene, that is addition of hydrogen and addition of halogen. Addition of hydrogen is called Sabatier-Senderen's method. Very important for 2 marks. Okay, next one. Another important question is ozonolysis. Ozonolysis of alkene. Next important question, polymerization of alkyne. Polymerization of alkyne. There are 2 important polymerizations. Among the 2, cyclic polymerization is very important. In this cyclic polymerization, what will takes place? So alkyne undergo a reaction can give a cyclic compound. I am taking here acetylene, CH triple bond CH. It is acetylene. One more alkyne I am taking, CH triple bond CH and CH triple bond CH. When these involves in cyclic polymerization, okay, this pi bond comes here and make a bond between these 2 carbons, and this bond comes here and make a single bond between them, and this comes here and make a single bond between them. Then what will happen? CH triple bond becomes double bond, and here there is a single bond is made, CH double bond CH. Here single bond, CH double bond CH, single bond. Okay, finally we got the structure. So this is nothing but benzene. Benzene is formed as the final product. Very important for 2 marks, compulsory question for 2 marks. Prepare benzene from acetylene. Prepare benzene from acetylene, or it is also called ethyne. Okay, that is cyclic polymerization. Next, preparation of benzene. Next question, preparations of benzene. Among all, preparation from phenol is very important. Okay, preparation of benzene from phenol is very important. Phenol is an aromatic compound which contains OH on the benzene ring, that is called phenol. When this phenol is heated with the zinc dust, okay, it is acting as one of the reducing agent which removes oxygen. This oxygen taken by zinc, and we will get benzene plus ZnO. Okay, in this way we can prepare benzene from phenol. Very important for 2 marks. Next, chemical properties of phenol, especially mechanism of chlorination of benzene. 3-step mechanism I have explained you and I made you to practice. That is very important. Next, mechanism of Friedel-Crafts alkylation, and mechanism of Friedel-Crafts acylation. Okay, among these three, one question is compulsory. One is compulsory for 3 marks. Among these three mechanisms, one is compulsory question for 3 marks. So that is about the important topics from the chapter hydrocarbons. Hydrocarbons chapter is only about the organic compound which is containing carbon and hydrogen. So try to read all these questions whatever I have explained in today's class, and that is enough for the final exam. Thank you.